This video is for Lab 1, Setting Up. In particular, it is for just the first part of Lab 1, corresponding to sections 3.1 and 3.2 of the Applied Analog Electronics textbooks. And that is, the first part is just getting the parts kit and identifying the various parts within it, making sure that you have all the parts that you're supposed to. The rest of this will be for the later videos. All right, let's take a look at what is actually in that parts kit. First thing is that we have a large box here. Now it's a little bit difficult for me to get the entire box on my document camera. I'd have to put it up on the ceiling or something. So I'm just going to have to try and remember to bring things over to where you can see them. I'm going to look at a list of the parts while I show you them, and that list of parts is from the Winter 2020 version of this course. Every year we end up changing somewhat the list of parts, and so you want to make sure that when you're checking your parts list, you're checking it against the right year's version of the parts, because it won't match for a different year. Okay, so the first thing on the list that I have here is a breadboard, and this is a standard 830 point breadboard. And we're going to be using this for doing just about all of our prototyping of circuits. Some circuits we will end up soldering into a more permanent form, but when we're testing and debugging, we'll be using the breadboard for just about everything. Okay, we have got a number of tools. We have got a flush cutter. Flush cutter is a pair of wire cutters where one side of the blades here is, the cutting edge is flush so that you can cut real close to a horizontal surface, and we'll use that for clipping off extra length of wires and stuff when we do soldering. Another tool you'll have is a wire stripper, and we've used different wire strippers in different years. The most successful ones have been ones like this, which have 20 to 30 gauge as the range that they can accept, and most of them have a little latch here for holding them closed, which is handy for putting them away in the kit. Incidentally, the kit originally was filled with these little yellow boxes that are removable. I've removed some of those boxes so that I can put the tools and the breadboard in here, things that are too long for the small boxes. We also usually have some sort of needle nose pliers. These are good both for holding wires when you have to do soldering and for putting wires into the breadboard. If you've got clumsy fingers like mine, it can sometimes be quite difficult to get the wire into the breadboard hole, and so particularly if you've got crowded conditions, and so it can be useful to have the pliers to hold it, and they have a lot less space, or need a lot less space around them than fingers do. So needle nose pliers are useful for many things. Okay, in addition to that, we'll have another device, a multimeter. The multimeters we use are cheap ones, but they have a number of useful properties. We can measure resistance or voltage, either DC or AC voltage with them. This one also has the ability to measure capacitance and to measure current. As it turns out, we don't use the current measurement at all in this course. Whenever we need to measure current, we're going to use our own sense resistor and measure a voltage. It's a safer way to do it, and it allows us to measure over a better range. Also means that the probes that we have are essentially always going to be hooked up to the common for the black and the volt ohms for the red lead. Now the probes you have will probably not be as nice as these. These came from a different meter. The probes that came with this original multimeter failed, and the meter that the good probes came with failed. So you will have probably cheaper probes than these. Let's see. Oh, the multimeter may or may not look exactly like this, even if it has the same model number, because there's probably like 50 different Chinese companies making multimeters using the same integrated circuit, and that's what this DT9205A comes from, is the name of the integrated circuit, but with slightly different switches and connectors on the outside. So it may look slightly different, but should have the same capabilities. And it's often a little difficult to get the probes to sit neatly in the box and still be able to close the lid. Okay, you should also have a screwdriver set. Now, I don't have one of the screwdriver sets that we include in the kits. They're nicer than the screwdrivers I have. The screwdrivers in the kit are usually these Stanley screwdrivers, which are much nicer than the cheap ones that I had from a previous year. And the idea of these is that the tip of the screwdriver can be held in place with your forefinger at the opposite end of the screwdriver, and then you can turn the screwdriver with your thumb and middle finger. And that motion allows you to keep the screw tip in the screw, which is often a problem if you try and do it with, sort of trying to hold it with what a lot of people think of as a screwdriver grip or a pencil grip. There's a little rotating part at the top here so that you can keep your finger there and still rotate the screwdriver blade. Okay, I think that's it for the big tools. Now let's look at some of the parts we're going to have. All right, we have got hysteresis oscillator board. This is a small printed circuit board that you will be using to build hysteresis oscillator on. And it should be one of those. You should have some red and black alligator clips. And what you'll be using those for is to attach to wires that then can be plugged into your breadboard, so that now you've got the ability to connect circuitry on your breadboard off to things that don't fit in the breadboard. And sometimes we'll use these with long wires, sometimes with short wires. Sometimes we'll put an alligator clip on both ends of a wire when the things we need to connect, not just a breadboard at one end. Okay, and as you can see, each year we end up with a different style of alligator clip. And it, again, depends mainly on what's cheap that year. Okay, we have probably a foot or 6 inches, I guess now is all we're doing, of silicone air tubing. We have a barbed fitting that the silicone tubing should just squeeze onto, and that barbed fitting should screw into a PVC elbow. And that elbow should be a screw thread on one side and a smooth slip fitting on the other side. And we'll be using this for our breath pressure testing. For the breath pressure testing, we need to drill a 2mm hole in the back. Generally, when we do these labs in class, the students go to a drill press and learn how to use a drill press to drill that 2mm hole. If we send the kits home with people, we probably have to pre-drill it for you because we can't send the drill press home. Okay, there should be a resistor assortment. And each year we get a different resistor assortment because each year a different one is cheap. This one was from one of the early years and we had 112 values. I think we decided that one was too expensive and we're using one now that's got more like 60 or 70 values. There should also be an assortment of small ceramic capacitors. And again, this was from an early year. We had 25 values here. I think we generally still have 20 or 25 values in the capacitor kits, but it's whatever's cheap that year. In the capacitor kits, you'll have a bunch of smaller bags, each one with its own, 5 or 10 capacitors of a given size. You should also have a USB-A to USB micro cable in your kit. This is for connecting up to the microcontroller board that we use for doing data acquisition. There should be some pins here for male header pins. And the idea of these male header pins is that they connect, there's two types. One of them connects breadboards on the long side to something soldered, like the hysteresis oscillator board or the microcontroller board. The others are double-headed pins, and you should have 40 of each. I've already used up a number of the double-headed pins here, so I don't have 40 left on this strip, but the white strip there with the solderable ones is about the right length. You don't ever want to solder the double-headed ones. What we use the double-headed ones for is we break them up generally into groups of 2 or 3 as we need, and plug them into the breadboard. So we've got, let's see if I can get you a good angle on that. Hard to see where it is, but it's got 3 there plugged in, and I can plug in another pair on the red and blue lines here. And these get used for hooking up to things like the Analog Discovery 2. Now the Analog Discovery 2 has got wires that end with a female connector, a female header, and so that can just slip onto one of these header pins and make a good connection to the breadboard. And that's what we use the double-headed pins for mainly. You don't want to use them up for soldering because they're too long for that, and you then wouldn't have them available for what we really need them for. Okay, so male header pins, the microcontroller board itself. Microcontroller board here has already got soldered on pins like these male header pins plugged into the breadboard. We also have a 3-pin female header sticking out the top of that, which gives us connection to 3 more points there. Next part of your lab is in fact going to be to solder on these male header pins and the female header. Okay, so those are the large parts there. Now we're going to have a bunch of smaller parts. You should somewhere in your kit have what's called a dip tube. That's for dual inline package, which is the type of packaging these chips have. And it's a tube because the chips are there in the tube. And I believe in this version of the kit we had 3 chips being provided. A small one, and you won't be able to read the writing on it. That's the INA 126PA chip. That's an instrumentation amplifier. You should have one that's labeled MCP 6004, which is a quad op-amp chip. And you should have one that's labeled 74HC14 by HC14N, and that one is Schmitt trigger. So those are your integrated circuits, and you should have, for this version of the course, one of each of those. All right, other little things we have. There should be a little bag with a bunch of even smaller parts in it, some Lego bricks. And here you can see that we've drilled holes in the Lego bricks. They should all be black bricks. And generally, in the past, we've had students do the drilling, again on the drill press in the lab. If we have to ship them to people at home, we may have to pre-drill some of the Lego bricks. We'll generally have 2 or 3 of these 1x2 black Lego bricks, and another 3 2x4 Lego bricks, which I didn't have in this old version of the kit. All right, what else do we have? There's this funny looking black thing in here. Let's dump these out. This is a thermistor, and this particular thermistor is epoxy coated so that we can dip it into liquid, into water without short-circuiting it. And we'll be using that for the first lab after the setup lab, the thermistor lab. And it's got very fine wires on the back here, 30 gauge wires, and you can see that this is already broken off on one of these. That's why we like to have wire strippers that go down to 30 gauges, because you may have to restrip this wire. Also in that kit we should have a screw terminal. This is a 1/10 inch pitch screw terminal. And what we use that for is it goes on the hysteresis oscillator board right in there so that we can have connections from the edge of the board here, and you can use your screwdriver to tighten down those connections on wires. All right, what else have we got in the kit? We should have a phototransistor. It'll probably come in a clear case. And we should have a red LED come in a red case. That's the easiest way to tell them apart. There should also be a diode, and that'll be used in the pulse monitor lab. There should be a female header. I did not have a spare female header here. That is the one that is soldered into the Teensy LC board. And incidentally, if you don't have a Teensy LC, the lab also will work with a Teensy 3.2, which is a somewhat more capable chip, but it costs more. So we usually use the LC board because it's cheaper. You may notice a theme here in trying to make things as cheap as possible. And I think, there's one other set of things you'll have besides sort of the packaging that everything came in, and that is you may have some larger capacitors. Now, what we do for those in the lab generally is we bring in these boxes of capacitors and have students pick out 4 of each of the 10 values, because it takes a long time to get the lab staff to pick out 4 of each value and stick them in a bag for you. For what we're doing for the at-home labs is we may have to take that extra time to put these all into the kit for you. But each of the capacitors is labeled, so even if you don't have this nice box with all the labels on it, the individual capacitors are marked here. And these are much larger capacitance values than the kit that had small capacitors in it. This kit had from 1 picofarad to 100 nanofarads, and this one starts at 100 nanofarads and goes up to 10 microfarads. So these capacitors are the larger ones, and we tend to use them for bypass capacitors. You may also need them occasionally for filter capacitors if you need to do a very low pass or very low frequency filter. And that's pretty much it for the kits that we did in winter. We may have, if we have to do an at-home kit, we may be sending you some other devices. We may send you a solder sucker. This is for removing mistakes when you do soldering. We may also be sending you a soldering iron and solder. We'll probably also have to send you wire. It'll probably be in long pieces, not short pieces like these. You'll end up cutting it up and reusing the wires many times. The wires we use are 22 gauge wires because those are the ones that work best in breadboards like this. You can also get away with using a slightly thinner 24 gauge wire, but those have a tendency to come loose sometimes, and so are a little bit harder to do debugging with if some of your wires are not making good contacts. And I think that covers pretty much your entire kit. So later video will tell you some more about what you do with them.